Hello friends, in my previous video I have solved a problem on trapezoidal section, and in this problem we'll solve on rectangular section. The problem definition is the crane hook carries a load of 20 kilonewton as shown in the figure. 20 kilonewton. The section at XX is rectangular. Here the section is rectangular whose horizontal side is 100 mm. The horizontal side is 100 mm. Find the stress in the inner and outer fiber at the given section. So we have to find if this is section at XX, we have to find the stress at inner and outer sections of the fiber. So this is what 100 mm, 20 mm width. So first the data force load is given, inner radius is given, from here to this is 50, from here to here it is outer radius, h is given as 100 mm and b is 20 mm. So initially we will calculate the area of section XX, that is area of a rectangular is equal to b into h, okay, breadth into height, that is 20 into 100, that is 2000 millimeter square. And for radius of curvature, the radius of curvature equation will find this radius of curvature is r actually, and minus rn, r minus rn, this e is equal to r minus rn, that is distance between centroidal axis and neutral axis. That is, see here, this is origin, if this is the origin, this is r, this is centroidal axis, origin to centroidal axis is r, origin to inner fiber, that is ri, origin to outer fiber, that is ro, and here c1 is the distance from the inner fiber to the centroidal axis, and c2 is the distance from the outer radius to the centroidal axis. Okay, so well, in this problem, see here, for a rectangular section, this is centroidal axis and neutral axis, ri, rn, rc is centroidal axis radius, and ro is outer radius. So here, so area we have calculated, and now e e equal to r minus rn. R is the distance of origin to centroidal axis, minus rn, same distance of origin to neutral axis, rn. So here rn equation is given in the data handbook, that is for rectangular section. You can see here this equation we have to use, zoom it, same equation I have written here. Okay, so same equation I have written. See here, in the place of r plus c, they have given r plus c, c2 it is r plus c2 and r minus ci. So r plus c, r plus c2, r plus c2 is ro, okay, outside radius, c2 c1. So r minus c1, r it is centroidal axis to origin r, minus c1, this c1, that gives inner radius ri. So r minus c1 is ri, this is c1, this is c2. Okay, so substitute 100, area is h is 100, log e 150 by ro is 150, ri is 50. So log e, while calculating in using calculator, in the place of log e, just press ln. Ln is there, ln of this value, you'll get this value for rn. This is rn value, I have continuously written here. So rn value is 91.02. For centroidal equation of a rectangular section is h by 2. This is centroidal equation. So r equal to, this is ri is from the inner radius to this distance, that is this distance from here to this distance is 50. So that's why it's 50 plus 100 by 200 is h by 2. Get r equal to 100. Substitute here. 100 minus 91.02 is e equal to 8.92. That is distance between centroidal axis and the neutral axis. Next, here distance between the load and centroidal axis. If this is the load point and this is centroidal axis, that is x equal to r equal to 100. We'll see 100. See, r value is 100. We have calculated here. X equal to r, that is equal to 100 millimeter. Next, bending moment about the centroidal axis. Bending moment equal to load into length. Next, direct tensile stress at section xx. So stress equal to load by area, so you can calculate the tensile stress. Next, distance from the neutral axis to the inside fiber. This one is from the data handbook. The equation number I'll tell you. See, the equation is here. This, at the inner fiber, the maximum tensile stress due to bending is this one, and at the outer fiber due to compressive force, the equation is this one. Same I have written here. Same equation 1, 10.1b. So inner fiber ci, you can see here ci and co outer fiber from neutral axis. So co you will get, ci here, rn minus ri for distance from the neutral axis to inner fiber, and this is for outer fiber, ro minus rn. And at the inner fiber, the maximum tensile stress due to bending shown in the equation. So ci value is here, co value is here. This is for inside, and here this one at the outer fiber. You can see the equation 10.1c. Substitute the value co, ro, everywhere, each value we have is substitute. Sigma o, outer stress at outer radius is, outer surface fiber is minus 44.08 Newton per millimeter square, that is 44.08 Newton per millimeter square, that is compressive load. So next is resultant stress at the inner fiber. Sigma t plus sigma I for inner fiber. Sigma t we have calculated here. 10. So sigma t is equal to 10 plus 91.97. We'll get this value, and at the outer fiber sigma t minus sigma o. So we have to substitute 44.08 minus this. So we'll get answer in terms of minus 34.08 Newton per millimeter square, that is compressive. Thank you.